Section 6.3, Part B. We dealt with radicals and multiplication. Now let's look at radicals and division, or radicals and fraction. Consider this first example, the square root of 64 divided by 4. We're supposed to do the division first. What is 64 divided by 4? 16. What's the square root of 16? 4. So now let's consider the next problem. The first problem, we took the square root of 64 divided by 4. We divided first and then took the square root. What happens if we take the square root and then divide? What's the square root of 64? 8. And what's the square root of 4? 2. And what is 8 divided by 2? 4. So let's compare these. We got the same answer. We swapped the order in which we did the square root and the division, but we got the same answer. The quotient rule for radicals: for any non-negative number a and positive number b and any index k, the square root of, or the kth root of a divided by the kth root of b is the same thing as the kth root of a divided by b. So you can change the order, and we can go the other way. The kth root of a divided by b is the same thing as the kth root of a divided by the kth root of b. And again, we have to be careful. This does not work for the square root of 2 over the cubed root of 2 or something like that. The indexes have to be the same. This rule does not apply unless it's the same root. So divide and simplify. What can we do here? We can reorder this. We can think of it as the square root of 800 divided by 8. What's the 800 divided by 8? 100. And what's the square root of 100? 10. 3 times the square root of 88 divided by the square root of 11. Now, the 3 is outside of the radical. It stays outside of the radical. Leave it out there. But the 88 and the 11 are both under the radical, so we can divide first. What is 88 divided by 11? It's 8. And can we simplify that? Sure we can. 8 has a perfect square as a factor. Do you know what it is? 8 is 4 times 2. And what is the square root of 4? It's 2. So we take the square root of 4, it comes out of the radical, but that other 2 has to stay under the radical. This has a square root, you take it, it comes out. The 2 does not have a square root, it has to stay under the radical. Now we had multiplication here before. It was understood that we had multiplication 3 times the square root of 8, 3 times the square root of 4 times 2. So when we bring that 2 out, we multiply it times the 3, and that gives us 6 times the square root of 2. And that's our answer. Look at this mess. This is hideous. What can we do about this? They're both cubed roots. So why don't we start by just making it one big cubed root and go ahead and do our division. We have 72, x to the 7th, y to the 8th, over 9, x to the 5th, y to the 7th. These problems are training you to think logically. They're training you to apply a set of rules that encompass different situations. So we have the cubed root. 72 divided by 9 is 8. X to the 7th over x to the 5th You subtract those exponents and you have x squared y to the 8th over y to the 7th. You subtract 8 minus 7 and you get 1. Can that be simplified further? Well, what is the cubed root of 8? 2. Can we take the cubed root of x squared? No. If you write that as a fractional exponent, it would be 2/3. That's not a whole number, so that's not going to help us. Can you take the cubed root of y? No. So that's it. That's our answer. Still looks a lot better than the original problem, so even though we don't feel like we've quite done enough, we've made it a lot better. We have to simplify and assume that no radicands were formed by raising negative numbers. So our first problem is the square root of 64 divided by 121. We can think of that as the square root of 64 divided by the square root of 121. The square root of 64 is 8. The square root of 121 is 11. So it's 8/11ths. Now, I want to talk to you briefly about how much work you have to show. Many of you would just look at this and say, oh, it's 8/11ths. And if you're taking a test and you write 8/11ths and everything's fine, you may want to show me this step in the middle, because if you mess up and you write 11/8 or you write, I don't know, 4/5 or something crazy that's not the answer, I'm not going to give you any partial credit. I need to know that you understand the rules. So this step in the middle is helpful. Even if you miss 8/11ths, it is helpful because it says to me, I understand the rule. I'm applying the rule. Your job as a test taker is to give me reasons for giving you partial credit. So the square root of 144, we'll put that in the numerator, and the denominator is the square root of y to the 6th. The square root of 144 is 12. Now that square root of y to the 6th, you can think of it as y to the 6th, that's the power. This is an exponent, doesn't look like it, but y to the 6 halves, because it's the square root. 6 halves is 3, so our final answer will be 12 divided by y to the 3rd power. Once again, I think those fractional exponents are helpful when you're dealing with variables. Cubed root. So it's the cube root of 8th. And let's go ahead and make that y to the what? 9th power, but it's the 3rd root. So it's 9/3 power over x to the 5/3 power, because we're taking the cubed root of that. The cubed root of 8 is 2. Y to the 9/3. 9 divided by 3 is 3. X to the 5/3. Now 5/3, if you divide 5 by 3, it's 2 2/3. So we can think of this as x squared times x to the 2/3. So we have our whole number and we have our fractional exponent. X squared, that's fine. It comes out of the radical. What about that x to the 2/3? It still has a fractional exponent, so it's the cubed root of x squared. I'm a little bit bothered because I still have a cubed root in the denominator, but that's something we'll talk about later. So that's all for section 6.3.